Hello, Professor Rad here, and today we're going to use the process of generalization to take the methods that we used to multiply whole numbers together to now multiply decimal numbers together. So we're going to find the same product two ways, once using the box method and once using the traditional method. So let's go ahead and start out using the box method to find the product of 12.6 and 81 hundredths. So just like with the traditional method, just like with whole numbers and the box method, I'm going to take each number and split it up into its component parts. I'm going to put the longer one across the top and the shorter one across the bottom, or the side. So 12.6, I'm going to write that as 10 plus 2 plus 0.6. And 81 hundredths, I'm going to write that as 0.8 and 0.01. So now we can go ahead and multiply, and we can use those theorems that we discussed in the last video. So that if you multiply and there are zeros at the end, then that tells you you can move the decimal point to the right that many places. And if there are zeros to the left, you move the decimal point left that many places. So let's go ahead and start out in this column with the 10. So I know that 8 times 1 is 8. And now I have to figure out where that decimal point goes. So because I'm multiplying by the 10, the 0 says that I need to move a decimal point to the right one spot. So there's an invisible 0 here. But multiplying by the 8 tenths says now I've got to move it back to the left one spot. So I get 8.0, or just 8. When I do 10 times 100th, I've got 1 times 1, which is 1. The 0 up here says I got to move that decimal point over and get a 0. But the 2 zeros here say now I have to move it over 1, 2 places, and I get 0.10. I'm going to carry on in this method. So 8 times 2 is 16. This is just 2, so this doesn't indicate any decimal movement. But this one says I got to move it one spot left. So after a whole number, the decimal point's just to the right, so I move it over one spot left and get 1.6. 2 times 1 is 2. And then there are 2 zeros to the left, so I have to move the decimal point 1, 2 spaces left, and I get 0.02. 0.6 times 0.8, I'm going to do 6 times 8 is 48. And then I have to move the decimal point one spot from up here, so it's going to be between the 4 and the 8, and one spot from the 0.8, so it's going to be in front of the 4. 6 times 1 is 6. I move it over 1 from the top, so it's here tentatively. And then there are 2 zeros, so now I move it over 1, 2 more spots, and I get 0.006. Okay, so now that I've got all of my products inside the boxes, I'm going to add across, just like I did in with whole numbers. So I'm going to write each of these actually out to the nearest hundredth because I've got to the hundredths place here. So I can do 8, 0, and 0. It's going to give me 8. 4 and 6 makes 10 plus 0. We have 10, but I've got a carried 1. So I've got a carried 1, and 1 makes 2, plus 8 makes 10. All right, now down here, I've got a tenth, 2 hundredths, and 6 thousandths. So that's a bit easier to add together. A tenth, 2 hundredths, and 6 thousandths. Put a placeholder here and add going down. 0 and 6 is 6. 8 and 2 is 10. 1 and 1 makes 2. Got my zeros and a 1. So 12.6 times 81 hundredths should be 10.206. Let's check that, see how we did. Hey, 10 and 206 thousandths. It worked out. Okay, so let's now try this product, but this time let's use the traditional method. So one of the things that's intriguing to me about the traditional method with multiplying by decimals is notice I didn't line up my decimal places. You don't have to. So when you use the traditional method and you multiply decimals, you are basically gonna forget about the fact that there were ever any decimals there until the absolute end of the problem. So we're gonna multiply these as if they were whole numbers. So I'm gonna do 1 times 6 and get 1, or get 6. 1 times 2 and get 2. 1 times 1 and get 1. Then I'm gonna have my placeholder 0 because I have to move over to the 8. 8 times 6 is 48. So I write the 8 and carry the 4. 8 times 2 is 16, plus 4 is 20. So I write the 0, carry the 2. 8 times 1 is 8, 9, 10. And since there's a 0 here at the beginning, I don't have to multiply by it. If I did, I would just get a whole row of zeros. So now I'm going to add down. We've got a 6, 8, 9, 10. 1 and 1 makes 2, 0, and a 1. So far, absolutely nothing has changed from how we multiplied with whole numbers and the traditional method until now. So at the very end is where we have the change. You look at all the digits that you multiplied by that were after a decimal point. So we had a 6 up here to the right, or after the decimal point, and then we had an 8 and a 1, for a total of 3 digits that were to the right of decimal points. That's how many digits have to be to the right of the decimal point in our answer. So 1, 2, 3, the decimal point will go here. So 12.6 times 0.81 gives us 10.206, which, fortunately, is what we got up top when we used the box method as well. All right, so that's how you can use those similar processes that we were using for whole numbers, but amend them slightly for decimals. And since these were some fun little processes here, a little complicated, I've got a few questions for us to try. So part A is some practice filling in the boxes for the box method. Part B is asking us a question about how many places after a decimal point we should be in our answer. C is using the box method, and D is using the traditional method to multiply. In our next video, it will be our last one about multiplying decimals, and it will be to help us check our answer for reasonableness, so that if we get an answer from a calculator that seems suspicious, we know that it's suspicious. So we can use some kind of educated guesswork to at least tell if maybe we accidentally typed something wrong into the calculator. So I look forward to seeing you then. In the meantime, have a fantastic day.